with Teradata AI. What is Teradata AI Unlimited? Is the database engine which no longer required persistency for managing the data. So what we done is we took the best in class execution engine to run in database functions and analytics, but we removed the need for managing and orchestrating the data. The assumption of this engine is it operates on the object store. So all the input and output data will be always stored and managed in the object store. They are not going to be managed by the engine. And with that allows us to create the transient engine. So the engine which you can deploy on demand, which means you are allowed to use it when you need it, have infrastructure only for the time when you are executing your requests. Once you are done, you can destroy the infrastructure and no longer being charged for anything. But it also gives you ability to redeploy this engine for the given project every time you want to restart your work or continue working on your data projects. This engine is designed for exploration and experimentation tasks. So it gives you ability to explore and analyze your data in the object store on demand when needed. We are not recommending using AI Unlimited for production workloads, as this is a transient platform which can basically is assuming that it's not owning any data. It's also built for the data team. So you will see how we are leveraging the GitHub or GitLab in order to construct the teams as well as to manage their analytical pipelines. In AI Unlimited, we introduce a little bit different architecture. So this infrastructure is run on your cloud. This is not a SaaS offering. That basically means that users are deploying the engines in their own cloud environment, and therefore they have access to their own object stores they have in their possession. As you can see here, the prime interface is for the users is Jupyter Lab, and this allows us to create a single tool experience. So user being in Jupyter is able to orchestrate the platform as well as to write queries against the engine once it's deployed. But to achieve this, we created the element called Workspace. So Workspace is an orchestration service which allows client tools to talk and interact with the engine as well as provision the engine and orchestrate the infrastructure. And as we said, GitHub and GitLab are used to not only formulate the teams or create the projects, they're also used to store and persist the definitions of the objects you have created. So for example, if you created a orange table as a way to represent your object store data, this definition will be restored back when you're redeploying the engine next time for your work. So that allows you to give you this continuation of work experience. With that, let's go and show you how this works. So once the engine is provisioned, the workspace is provisioned, and the first step you will see is you will go to the port 3000, and if you are the user or the owner, you have a profile page. To get to the profile page, if you are owner, you have to press the profile button, and this will show you the API key. And this API key is important because it's going to be used by Jupyter in order to create the secure connectivity between the Jupyter as well as the workspace. So now, being in Jupyter, the first thing is you're going to create a new notebook. In the new notebook, first command you have to run is the workspace config, and this allows you to configure your Jupyter to talk to the workspace service, where you have to specify by providing the IP address and the port 3282. And then the API key, which you got from the profile page. Once this is done, we can now create the project. What we have to specify here is the name of the project. In our case, we will use the name Legion Demo. Environment will be AWS. If you are using Azure, you will put here the name Azure. Now project is created. We can list the project. As you can see, now I have the Legion demo project created, and it's automatically created a repository in my GitHub account in my personal space under the name Legion. So now what I can do is I can create also project-based authorization. So this will allow me, my engine, once it's provisioned, to talk to the object store. So now we're going to create a shared authorization for the project team. We can do this by typing the command project authorization create, name of the authorization for the project Legion demo, which we created just before. So now the authorization is created. So we can list authorization for our project. As you can see, we were using only the key and the secret, so simplify authorization. You can also use token, you can use role and external ID to assume the role you are given if you are using the shared authorization. If you are planning to use a user-based authorizations, you don't have to do this step because you will be creating your authorizations on demand once the engine is deployed. So now we have authorization, we can deploy the engine. So to deploy the infrastructure, the first thing we have to do is type the command project engine deploy, name of the project. As a bare minimum, we just need to specify the size of the node. If you want to use more than one node, you can do this by typing a parameter node equal to or 3 or 4. We recommend to start small, and then while experiment is executing, you can decide if you want to deploy more. So in our case, let's start with the default one node of the size medium. As you can see, we don't have to specify anything more. This is just as simple as it is to deploy the engine. Now it's going to take approximately up to 7 minutes to deploy the infrastructure on AWS. So now the engine has been deployed, and by this, it also created the user and a randomly generated password for that user. So once the engine is deployed, if you go to the connection manager in Jupyter and refresh, you will see that you automatically have the connections defined to the engine. Now, if you miss this window, you can always list the engine for the given project. So we can type the command project engine list on demo, and that will show us the public IP and private IP depending on your configuration. Those are the IP addresses you have to use in order to access the engine. But because we are in Jupyter, we don't have to use IP addresses. IP address is already deployed into the connection name. So now we can copy the password. And now let's say I want to do the data exploration. So now I have to connect to the engine, which is in our case the name of the project. I'm going to paste the password. And now let's create our example weather forange table, which relies on the data MyS3 bucket. Now the table is created. I can run the first query just to understand the null percentages in my values in the table. You can see the result in the tabular form. I can also chart the results by using the chart magic. So now we have this table, and let's say we want to do some other tasks, maybe some data cleaning. As you can see, it could be also another day, but in our case, let's just connect. And remember, each notebook is an independent session in Jupyter. So every time you open the new notebook, you have to reconnect to your engine. So now we are connected. And we can now say, okay, we've done this analysis. We know how many null values we have. Maybe for now we would like to generate the values. So because we don't own any data, the only option for us is to create a view where we can replace the values by using the td simple input feed function. And now we can do the transform function. Now let's see our feed table view. As you can see, we already put the values, so the nulls were replaced. And that's an interesting way of doing the tasks like data cleansing. You can also do additional histogram just to see how things are changed after we created a new values for the nulls in the table. And again, this is standard Jupyter functionality for running SQL queries, where we can visualize the results as well as put a charting function. So if you don't want to use the tabular form, you can always do the graphical representation. And let's say now we want to do some hypothesis testing. To do this, again, we have to create the connection. And in this example, when we want to test the TD ANOVA function, the thing we need to create is create additional small table which will contain the values which are used by the ANOVA function by creating the HPT input view. So it's now created. I can always visualize this by running a simple top 30. And then we can run the ANOVA function based on our input table, which we just generated. So as you can see, AI Unlimited gives you those options of executing any ClearScape functions Teradata has as in-database functions using the SQL. It's very easy way to interact with the data, doing your analytics. And once you are done, let's say we are done for the day, we've done our data exploration, we've done our small data cleansing, we tested the hypothesis, but we are running out of time of the day. So now we would like to stop our work, go back home. And to do this, because we don't want to be charged, we can go back to our notebook and say, now I'm done for today. Let me shut down the infrastructure. So to do this, I have to type the project engine suspend, name of the project, Region demo. And when this is executed, what is happening now is we are destroying your cloud infrastructure. So when this is done, there is no more infrastructure for you to use. Therefore, there is no charges happening. But the beauty of the GitHub is that because we created all those objects as a foreign tables and views, next time I redeploy the engine for this project, all those objects will be deployed back, so I don't have to go and re-execute the same steps. Those steps will automatically be done for me. And to look at this, we can go to our GitHub account. If you go to .td, a schema SQL file, our weather foreign table definition is here, as well as our views. So the next time I deploy the engine, all those definitions will be restored. And because I'm using the shared authorization, there will be no problems restoring the schema, and I can continue my work. So as you can see, this was just to show you how easy it is to deploy the infrastructure, be in the single tool like Jupyter, and interact with the engine. Thank you.